What's up, guys? Welcome to our lesson number 3 using passive buzzer from the automatic starter kit. Now we're gonna use Raspberry Pi as always, the breadboard, jumper cables, a resistance, a transmitter, and the passive buzzer. Now we're gonna set up almost the same as the lesson number 2, but the only thing is gonna be the coding different from this lesson. That's gonna help us send different frequencies. We're gonna put the buzzer again, and then we're gonna put the transmitter not next to that, but a little separate to not get confused or unable to connect something. The transmitter, the buzzer is kinda little hard to connect them because the breadboard is kinda new. And then we're gonna pull now the NPN transmitter is 8015. So we're gonna use the jumper cable, one of the jumper cables, and send it to the buzzer from the transmitter to the jumper cable. We're gonna check which is connected because it's gonna be when you pull power goes onto one line. And then that's the only different jumper cable we're gonna use. The rest is gonna be from the Raspberry to the breadboard. And this is gonna be we're gonna pull a resistance right now on the second pin from the transmitter. The resistance is gonna be at 1K resistance. And then we're gonna pull the jumper cable, but before that it's gonna a little hard not fixing but able to connect the resistance to the breadboard. You're gonna put it right here next to this second pin on transmitter. That part is gonna be one section different from the buzzer. Then we're gonna connect the second jumper cable. The jumper cable is gonna go to the pin number 12, and then the two left jumper cables is gonna be one to the 3.3 voltage and the ground. Always connect some to the ground to avoid burning or destroying something. Mix it up the Raspberry Pi or the buzzer or the transmitter. So we're gonna do, I'm checking what goes to the next pin because it's kinda a little hard to see. And then the last jumper cable is gonna go to the ground. The second pin is gonna go to the 3.3 voltage that goes to the buzzer, and then the ground is gonna go connected to the transmitter. It's a little separate to avoid making mistakes like that. When you're making a project, it's better to separate a little to avoid if we got an error, something like that. So we got connecting everything right. Now we're gonna go to the computer and doing the coding. We're gonna do, as always, Nano is a program where we're gonna write the code, and our file name y dot point py means Python. So we're gonna do our coding right now. As always, imported RPI means the pings from the Raspberry Pi, the sign, and the bus. Right here, I got a mistake. I was putting 11, but it's gonna go to 12. Yeah, and then we always set up our pin, but now it's gonna be a little different. We are not gonna define a lot of stuff as the other last two programs, but because it's gonna be just sending frequency. And then we're gonna do p equals to the frequency section. The p is equal to GPI point PWM. We're gonna pick the channel and the frequency. We're gonna start with 50, and then the p that starts DC, which is the frequency starts, and then we're gonna do the trial. Well, the statement is true. He's gonna make the sound to 100,000 and 100 frequencies, and then we're gonna do the beat change frequency to F. It means F is 100, 200, or 2000. After that, we're gonna do another line of coding, and then we're gonna change, but the second line is gonna be different from 2000, 100, negative 100 frequency, and then always the time sleep. So we're gonna do the 0.2, and then after that, always the key from interruption, and then it's gonna stop the sound, and this is gonna be how you're gonna hear the sounds. We're gonna save it, and then we're gonna check the sound.